Now we can get around Android Studio quite well. We know how to configure it, we know how to create a project, we know how to build an application, and we even know how to debug within it. But what if we have performance issues? Let's say we have a memory issue. How would we go about searching for that? One thing that we can do is leverage a powerful tool built within Android Studio called the Memory Monitor. The Memory Monitor is quite powerful, but quite simple too. It just tells you how much memory your application is consuming. Now I can leverage this within my virtual device, or I can leverage this within an actual device. To demonstrate this, I'd like to run another debug session with the same application that we've been using, but first I want to show you where the memory monitor can be found. If you don't already see it on one of these buttons on the perimeter of your screen, mine is right here actually, I could press this and it would be activated. But if you don't see it, just go to the Tools menu, click on Android, and then off to the side, there's a memory monitor. You can press that, and that'll bring up the tool. So here's the tool, and you can see I'm already debugging my Hello Android application. Let's switch to it for a second. Now you can see that it stopped at the first line of calculate sum, where my first breakpoint was since we got started. You can also see the memory bar streaming from right to left under memory monitor. The light blue line represents your free memory. The dark blue line represents your allocated memory. Off to the left, you can see the points of memory that it's referencing against. Right now you can tell not much memory is being used. I think I might have a memory issue, and I think it might happen during these calls. So let's find out. As we step through the code, the next line will be a call to search. There was a breakpoint at the first line of search, so it stopped there, and still the line is flat. So we know the memory usage was huge, jumping to another method. Let's step again. Again, everything looks fine. Step again, everything looks fine. It's flat. Everything's still fine. But you can see the next line of code is an allocation of a 2 million integer array. Now I suspect the memory may jump here. And it certainly did. I know at this point that there is a large memory consumption, but I also know this is a temporary variable. It's only available within this method, and it will go away as soon as I return from this method. So let's see what happens. I'm going to resume, and I don't see that the memory was reclaimed. I see that there's a bit more memory available, so it appears that Android has made available more memory for me based off of the light blue line there, but it certainly isn't going down. Let's try forcing a garbage collection. This icon here will initiate a garbage collection, so let's press it. Now we can see that the memory was instantly reclaimed, and we know this wasn't a big issue, as the garbage collector was easily able to reclaim this memory, and most likely it would have reclaimed this memory at an opportune time. So we didn't have a serious problem, except maybe a coding practice violation. Regardless, this memory would have been reclaimed and we didn't have an issue.